Okay, let's take a look at the Stinky Exponential. All right, so first, before we solve this problem, the question is asking, when is the left-hand side equal to the right-hand side? So let's visualize that for just a second. The left-hand side is the equation L of x is equal to 5 raised to the x plus 2 power. That is an exponential function moving to the left 2 units. So left 1, left 2 units right here. The exponential function always crosses as 0, 1. So you have that point right there. That point right here at 0, 1, right? And then so if you think about moving left 2, you have this new y-axis right here, and the x-axis stays the same, right? So 0, 1 is right there, and since the base is 5, you would go over 1, up 1, 2, 3, 4, 5, and over 2, up 25, but it will be way up there. Okay, so you'll just say that it goes way up there. And then here, over left 1, 5 to the negative 1 exponent is 1/5, so it's going to be down here. And it is going to have a horizontal asymptote. And that is how the exponential equation would look like, right? So that's the left-hand side. Now, the right-hand side. Right-hand side, the equation is going to be 4 is the base raised to the 1 minus x. I'm going to go ahead and factor out the negative because that would be our rotational reflection right there, right? It's going to rotate your graph. And then when I factor out the negative 1, I would have x minus 1 because negative times a negative is a positive 1. So here I am going to move to the right 1, and then I am going to rotate. And we are rotating because the negative is with the input. So let's go and move right 1. And so when I move right 1, I have a new y-axis right here at 1. The point that the function will cross is going to be at 0, 1 because 4 to the 0 power is 1. Normally I would go right 1 up 4 to the, but now I am rotating, so I'm going to go left 1 up 4. 1, 2, 3, 4. Left 1 up 4. And then normally I would go right 2 up 16. I'm going to now go left 2 up 16, which will be all the way up there. And then on the other side, it's going to do this because we know that the exponential function has a horizontal asymptote. So now if we look at that, we would say, well, there must be a solution somewhere right there. Okay, now let's go and find that solution. So how do we find this solution algebraically? Well, to undo exponential, we would have to use log, right? So here, we have choices here. Do we want to use log base 5, log base 4, natural log, or log base 10? Because those are the ones that we can use the calculator for. Okay, so it's your choice. You can use whichever log you like. Okay, now I am going to use ln because I know my calculator will do ln. So I'm going to go ahead and take ln of both sides, just like how you would square root both sides when you have an equation with exponent 2, right? Here, to undo exponent, I will use log. And in this problem, I am going to use ln, which is log base e. I'm going to take ln of both sides. Okay, and when I do that, I would have ln of 5 to the x plus 2, and then ln of 4 to the 1 minus x. Now, why did I use ln? What was my rationale? I just know that I can use my calculator to do an approximation when I have ln or common log base 10. So I'm going to use ln just because I can use a calculator. All right, now property of log said when I have an exponent that could go up in the front, the same here on the right hand side. So I have x plus 2 times ln of 5 is equal to 1 minus x times ln of 4. ln of 5 is a number, so to solve for x, I would have to distribute, and I would have to distribute on the right hand side as well, so that I can go ahead and move things around, get x's together, right? That's just the logical steps for solving for x. So ln of 5 times x is x ln 5, and then ln of 5 times 2 is 2 ln of 5 is equal to ln of 4 times 1 is ln of 4 minus ln of 4 times x is x ln of 4. Okay, now to solve for x, again, I would have to go and get all the things with x together and all the things without the x on the other side, so I can combine like terms, manage the scenario, right? So x ln 5 stays right here. I'm going to go ahead and add x ln 4 over to here, and then subtract 2 ln of 5 to the other side. So ln 4 minus 2 ln 5. So what's the trick here? I see x and x, so that's the greatest common factor, right? So x is a common factor, so I will go ahead and factor out the x, and once I factor out the x, what do I have left inside? ln of 5 plus ln of 4 is equal to ln of 4 minus 2 ln of 5. I'm going to use a little property of log here and put the 2 on top as an exponent, so that would be ln of, I mean to write ln of 25. ln of 5 squared, which is 25. Okay, so to solve for x, I would go ahead and divide by this right here. So x is equal to ln of 4 minus ln of 25, all divided by ln of 5 minus ln of 4. Now, depends on what you would like to do at this point. You could use your calculator and get an approximation here. Okay, so use your calculator. To approximate here, just type that in the way it is, or we could use property of logs and make this nice. Okay, condense that into one log, so that equals to property of log says when I have subtraction of 2 logs, that becomes division, so log of 4 over 25 divided by ln of, oh, oopsie, that was a plus, wasn't it? That was plus ln of 4. So here, when you have addition, it becomes multiplication, so that would be 5 times 4, and that is 20. Okay, we could go further and say, hey, look at that. That we can use change in base, where 20 would be my base, and that would be my input right here. Going backward of changing base rule, so I will have log base 20 of 4 over 25, and that is being condensed into 1 log. So that red part could be your solution, or this black part right here could be your solution, or you can use your calculator to get an approximation if you want a decimal approximation. All right, that is how we solve a stinky log equation. Now, do you have to use ln? So no, you don't have to use ln. Okay, you could use any other exponent you want. So I'm going to go ahead and do that same problem. Okay, I'm going to do that same problem, but go ahead and use a different base so you can see how that should look like. So the problem said 5 to the x plus 2 is equal to 4 to the 1 minus x. So as I said before, I could use log base 5, log base 4, because those are the two bases there, or I could use ln because I can use a calculator, right? So here I'm going to go ahead and do the same problem, but I'm going to go ahead and use log base 5. So I'm going to go ahead and take log base 5 of both sides. Okay, now what will that do? Well, first of all, the exponent here get to go in the front of the log, and same to this one, right? So I will have x plus 2 times log base 5 of 5. But what do we know about log base 5 of 5? It is 1. So I don't need to be writing that. I can just say that is 1 times x plus 2, which is just x plus 2. Or we can think log will undo exponent since they have the same base, because these are inverses of each other, and I will get the input, which is x plus 2, is equal to, in this case, the exponent will go in the front, 1 plus 1 minus x actually. 1 minus x is equal to log, not equal to, multiply to log base 5 of 4. Okay, now in order to solve for x, I need to get x's to one side. So I need to go ahead and distribute, because log base 5 of 4 is a number. Remember that, that's a number. So I take that number and I distribute so that I can move things to the left-hand side to combine with the other x on the other side, right? So here's x plus 2 is equal to log base 5 of 4 times 1 is log base 5 of 4 minus x times log base 5 of 4. Okay, now this right here, I'm going to go ahead and add it to the other side because that is where the x is right now. So I have x plus x log base 5 of 4 is equal to, and I'm going to go ahead and subtract the 2. So I will have log base 5 of 4 minus 2. X and x, I can factor out an x, and that will be 1 plus log base 5 of 4 is equal to log base 5 of 4 minus 2. And I like to just use the parentheses there just so I know it's log base 5 of 4 and then subtract 2, not 4 minus 2, right? All right, so the last thing to do is go ahead and divide. So this would be, and you know, sometimes I just write the number in the front, negative 2 plus log base 5 of 4, and it just presentation wise, it just look a lot better than having that parentheses and then minus 2. So then here I would have 1 plus log base 5 of 4 on the denominator. So that is the exact answer to this same problem using property of logs. Now the question is, well, is that value the same thing of what you had before up here? And the answer is yes, right? The answer is yes, because it's the solution to the same problem. So you can go ahead and actually use property of log and get from here to that red answers up earlier. And that would be something fun to do on your own. Okay, that is it for this exponential equation.